today we're going to be looking at the 2020 Maths Methods Queensland Short Answer Solutions. So these are the ones that are technology active, and I'm going to be using the TI-84Plus to go through the solutions with the hope that that will be helpful for students in Queensland who are using this same technology. So the first question on the paper looks with a sugar company sampling packets of sugar, and it finds that 5% of the packets are underweight. So we're considering a batch of 20 packets, and we want to determine of those 20 packets, how many can the company expect to be underweight. So this is just quite a straightforward calculation question. When we're finding an expected number, we take the probability, we multiply that by the number of things in the sample, and that gives us our expected number. So we would expect out of a batch of 20, 5% chance of them being underweight, there would be one packet that would be underweight altogether. The next part asks us to determine the variance of the batch. Now, quite a similar, again, 1 mark, straight calculation question. Variance, we're multiplying the number in the sample by the probability that it is underweight, multiplied by the probability that it's not underweight. So they're multiplying by 0.95 as well. So here we've got 20 times by 0.05 times by 1 minus 0.05, and overall our variance would then be 0.95. The last part of this question asks us to determine the probability that at most one of the packets of sugar in the batch is underweight. So therefore, if we're looking at most one, that's the probability that we've got less than or equal to 1. Okay, we're either looking at the probability of 0 or we're looking at the probability of 1. Now I can do this question using my calculator. So if I go into distribution, so to get to distribution, we go second, we press the variance button there. I'm looking at my, this is a binomial distribution. They're either underweight or not underweight. So if I press the up arrow here, that gets me through to my binom PDF and my binom CDF. Now in this case, I want to use binom CDF because I'm looking at the probability of 0 or 1. If it was just one or the other, or if it was just one value, I would use PDF. So if I go into my binomial CDF, my trials, that's the number in the sample, so 20. P is my probability, 0.05. And we're looking again, either 1 or 0. So I use the biggest value, so my X value is 1. And just remember that the calculator can't ever do a probability of a greater than value. So as long as your probability is less than, we're going to get the right amount here. I'm going to paste that into the main screen, and therefore I get the probability of 0.7358. So there's a 73.58% chance that at most one of the packets of sugar is underweight. And again, just remembering whenever you're doing the exam, it's probably a good idea to copy down whatever you write on your whatever you see on your calculator screen. Write that down, and just in case you get a value incorrect, then your marker can look at that and hopefully see that you've done, the right thing. The second question, we've got the rate of change in population for 2 cities. So city A is this rate of change of the population, city B is this one. So we're looking at the number of years since 2018, so that would be my first year, that would be my time 0. And both of these are measured in people per year. And we're told, we've got this extra information here, which is going to come in handy in just a second. We're told that at 2018, city A had a population of 5,000 and city B had a population of 3,500. So the first part of this question wants us to determine the population model for both cities. So if I take city A, and I've already done the algebra here, we can see that we're looking, when we're going from a rate of change in a population back to finding the population, we're looking at the integral of that rate of change. So my integral for a dash of t dt is equal to, I can take out that 45 as a constant, so it's equal to 45 times by the integral of t plus 1 to the power of -1 dt. Hopefully, we can see there that the power of -1, that makes this a nice kind of common integral question to do. That becomes, when we take the integral, 45 times by the natural log of t plus 1 plus c. Now we've got to go back and have a look at that information we were giving at the beginning. So we know that at the start of this time, when time is 0, our initial population was 5,000. So therefore, that means that C value is going to be 5,000 on there, because that's when time was 0, we had that population of 5,000. And when you sub in 0 into a log, that becomes log of 1, and log of 1 is equal to 0. So we would have to add on that 5,000 to make that up to the initial amount. For our city B, again, all the algebra is done for you here. So we're looking at the integral of b dash of t. So we're taking out that coefficient of 105, and we've got our integral of e to the power of 0.03t, and we're integrating with respect to t again. We can divide by that coefficient of t, which is 0.03. That gives us 3,500 e to the power of 0.03t plus c. And in this case, our population was 3,500 at the initial time. So b of 0 is 3,500. Now, if I sub in 0 into that t, that gives us overall e to the power of 0. So we multiply that by 3,500, and that is our initial amount. So we don't have a c value on there. C would be equal to 0 in that case. From here, I've just put these equations up the top here, just so, because we're going to refer back to them throughout the rest of the question. So for B, we're using our information that we found in 12A to predict the population of city B at 2028. So again, just a 1-mark question. 2028 is 10 years on from 2018. So I'm going to sub in 10 for T. So we're going to have 0.03 times 10. And there I can see, sorry, put that in twice. We can see there 4,724.5. And I would round that up to 4,725 altogether, because we can't have 0.5 of a person. Part C, we're using the information in 12A to predict the year in which the population of both cities will be the same. So we're finding when is city A the same as city B. There's a few different ways we could do this on our 84 calculator. The way I'm going to show you first is using the numeric solver function. So in the numeric solver, we can find any two equations that we want to be equal to each other. So in my equation 1 here, I'm just going to type in that first equation. So 45, the natural log of x plus 1. Now I'm using x instead of t because that's the standard variable that the calculator likes to solve for. So x plus 1 plus 5,000. And in my equation 2, I'm going to put in my b equation. So 3,500 e to the power of 0.03x again. And as long as those two variables are the same, the calculator will solve to find x where they're equal to each other. So I'm going to go OK. And then I'm going to press solve. And we can see there we get x equals 12.66. So in 12.66 years, the population would be the same. And if I add that on to 2018, in 2030, at some stage in 2030, the population will be the same. So that would be my final answer there. And the other way that you could do this question is you could solve graphically. So if we wanted to find where the populations are the same using the graph, we could have 45, the natural log of, again, x plus 1 plus 5,000. And then I could have 3,500 e to the power of 0.03. Again, we're using x as we did when we're graphing. Then from here, I'm going to go to zoom, and I want to go to 0, which is zoom fit. And that should kind of highlight the area of the graph that we're interested in. So if we go to zoom fit, here we can see that's where our intersect is from our graphs. So if I go second, calc, and then to the intersect, which is number 5, from here, all I have to do is press enter once on each of my graphs and then find around about the point of intersection. It doesn't have to be perfect, as long as you get kind of close to it. Press enter again, and there I can see my point of intersection is where x or t, as the variable in the question, uses 12.66. All right, moving on to the third question, question 13. So An online retailer claims that 90% of all orders are shipped within 12 hours of being received. On any particular day, we've got 121 orders altogether, and 102 orders were shipped within 12 hours. Our sample proportion is just the number of things we're interested in divided by the total number of things altogether. So in this case, sample proportion 102 over 121 is 0.84. Part B, we're looking at the distribution of the sample proportions of all orders shipped within 12 hours of being received on any days approximately normal. So in this case, we're looking at the normal approximation to the binomial. If we're assuming that our online retailer claim is true, we want to find the probability that in a random sample of 121, less than 85% of all those orders are shipped within 12 hours. So in this case, we've got to do a little bit of stuff first. So we can look at our mean of our normal approximation to our binomial is our number altogether times by the probability. So we know we've got 121 orders and 90% of those are shipped within 12 hours. So we would expect that overall, if we're assuming that our claim is true, that 108.9 orders have been shipped on time. What I'm going to do is I'm going to store that value as A, and then hopefully when we come back to it, then I don't have to remember all these values off the top of my head. As long as I remember what variable I store them under, that will help me later on. We then need to find the standard deviation. So to do that, we're multiplying the number in our sample times our population proportion times by our not population proportion. Okay, so in this case, we've got 121 times by 0.9 times by 0.1. So that's 10.89. Now that's the variance. So we then need to take the square root to find our standard deviation. We get 3.3, and I'm going to store that under B. So I've got my mean stored under A, my standard deviation stored under B. Again, just in case you don't know, to store, you're just using the STO with the arrow, and then you're using the alpha key to select any letter that you like featured in green. We then want to find what is our percentage that we're trying to kind of prove or find. So we've got 85% of 121. So I'm going to multiply 0.85 by 121, and I'm going to store that under C as well. All right, from here, we're wanting to find our probability with our normal distribution. So I'm going to look at the normal CDF function. Again, that tells us the probability within a certain range of values. And I'm looking at the probability that less than 85% of the orders. So I'm looking at the bottom part up to 85%. So my lower value is going to be negative E99. That's the lowest value the calculator can possibly kind of comprehend. And then my upper value is at 85, which I put in variable C. So I'm going to type in alpha C in there. The mean I'm going to put in A, and the standard deviation in B. I'm going to paste that in, and there I have 0.0337 being my probability. C, use the result from 13B to evaluate the reasonableness of the online retailer's claims. So 2 marks, as long as you're referring back to 13B and you're evaluating that reasonableness, that will get you the 2 marks there. So obviously, quite a small probability. Question 14. This is looking at a cumulative distribution function. So we've got f of x equals 2 minus 10 over x between the values 5 and 10. So we want to determine our probability density function. So in order to determine our probability density function, we're looking at the derivative of that cumulative distribution function. So we don't need to do anything with the 0, that can stay as 0 and otherwise. The first part of our function, we would bring the x to the power of -1, we would bring that -1 power down, multiply that by the negative, that then makes that a positive, and then we increase the power on the x by 1. So that becomes 10 over, or in this case, decrease it because it's negative, so that becomes 10 over x squared between those same values, 5 and 10. Then we want to determine the probability that x is between 5 and 7. So now we're using that same probability density function that we found before, and we can do this just by subbing in 5 and 7 into that probability, or we can integrate 5 and 7 into our cumulative distribution function, or we can integrate that derivative between the values of 5 and 7, and that's what I'm going to do in this question. So I'm going to find my nice little integral template on the calculator. To do that, we go alpha, the window button, and we're going to go number 4, which is our integral. You can also find that through the math menu, but that's just a little kind of quicker, easier way to do it. My upper limit is 7. My lower limit is 5. My function is 10 over x squared, and I'm deriving with respect to x. So I'm going to hit enter. There we go. There's my probability, 0.5714. There we go. Like I said, if we wanted to, we could just sub in, because we're integrating, so we've already found the derivative. If we integrate, we go back to our original. So if you do want to, you could just do that using your original function. And a nice way to kind of do that would be if you inputted your original into your y1. So we had 2 minus 10 over x. Now, if I go back to my main screen, if I want to quickly kind of get a value after I've substituted it into a function, I go alpha F4. I put that function into y1, so I can select y1. I can make that y1 of 7. That's my highest value. And then I can take away my y1 of 5. Essentially what we've done when we've integrated, we've just integrated and then minus the upper limit, minus the lower limit from the upper limit. So again, same thing here, we've substituted in 7 and 5, we're minusing the lower limit from the upper limit, hitting enter, and that should, if I have this in right, should essentially give us the same answer. If I just convert that to a decimal, there we go, we can see that those probabilities are identical. Okay, question C, we're determining the mean time between the arrival of the trains at the station. So to find the mean, we're multiplying our probability density function by x and integrating between the upper limit and the lower limit. So I'm looking at the integral, in this case, from upper limit of 10, lower limit of 5 of x times by 10 over x squared with respect to x. Enter, and there I get 6.93. So that is my my mean time of arrival of the trains at the station. Question 15. So in this case, we've got a field being divided into 5 sections. We're told the width of each section is 1 meter, and the perpendicular height of each section is given in the diagram. So we essentially know, without knowing the x value, we kind of have a y coordinate. If you imagine this image on a graph, the area of the field is found using the trapezoidal rule, and that's found to be 11.12 meters. So I want to find the height marks X on the diagram. I'm going to do that using the same numeric solver function as I did before. So if I go into C here, math, then up there, I'm going to delete the equations that I had before. And in equation 1, I'm going to put in my trapezoidal rule equation, but I'm going to have x instead of that value of f of x from that function. So the first thing is my width is 1, so that means that my delta x on 2 is just going to be a half. From then, I know that the first and the last values, we just have one of those and we add them together. So 1 plus 1.76. Then I've got 2 times the other in between f of x values there. So I've got 3 plus 2.6 plus 2.2 plus x. And there's my whole trapezoidal rule. I'm going to let that equal to the area that was found in the question, so 11.12. I'm going to hit OK. You can see that that's the same answer that came up before, but if we just go solve again, it will solve. I can see that's 1.94, and I'm going to evaluate my question and see that that part of the graph lies between 2.2 and 1.76. So I'm pretty happy with 1.94. The next part is then just straight determining the area of the field given by the model, and we can do this on the calculator as well. The only thing I would mention here is we probably want our answer to be around about that 11.12. We know the trapezoidal rule is pretty good at approximating, depending on what your delta x is, but it's not perfect. So again, if I go alpha, window, get my integral up, from here I'm looking at the values between 5 and 0. Then I'm going to input my function, so 4x over x squared plus 1, and then I'm going to add 1 to the end as well, and I'm integrating with respect to x. I'm going to press enter, and there my actual area is 11, according to integration, is 11.51 or 52 if I round up to 2 decimal places meters squared. There we go. Question 16. So this is a 4-mark question, and from here we kind of lose a little bit of the scaffolding that the exam's been giving us so far. So these next questions are a bit more open-ended. For this one, we've got bottles of soft drinks contain a mean of 591 ml, but there's some variation. Any bottle below the 20th percentile is rejected, and 35% of the bottles contain 593 ml or more of soft drink, and we're assuming that they're normally distributed. So I've just got a little summary of the information in the question here. Mean equal to 591. Probability that x is greater than 593 is 0.35. And if some value, if we've got some value that's in that bottom 20%, from that value and under would be rejected. So the first thing I'm going to do in this question is to use the information that we're given in the second part here, and I want to find my standard normal distribution value. So I'm going to go into distribution. In this case, I'm going to use my inverse normal because I want to find what that z-score would be if we had a mean of 0 and a standard deviation of 1. So the area is 0.35. We're looking at the left-hand, also the right-hand area in this case, because it's where x is greater than that value. So we're looking at the right-hand area. I'm going to paste that in, and we can see that we get 0.3853. So that's telling me that that 593 is 0.3853 standard deviations away from my mean value. Now, what's the point of that, you might ask? Well, the point of that is now I can use my z-score formula, which is x minus the mean divided by the standard deviation, to solve and find what my standard deviation is, because I wasn't given that information in the question. So from here, I can take, and we might do this using the numeric solver as well. So in here, I can make my equation 1. Well, that would be 593 minus 591 is just 2. So I'm going to make that 2 over x, because we're solving for the standard deviation. And I'm going to find where that's equal to 0.3853. So I'm going to hit OK. And again, I can see that's 5.19, which is what I've got written down here. So 5.19 mil, that's my standard deviation. from here, I can then use the standard deviation and I can use the information about the 20% being rejected to now find what that value would be. So again, I'm going to use my inverse normal because I'm going from a percentage back to a value. And I'm going, or sorry, I shouldn't say percentage, I should say from a probability back to a value. So I'm using my inverse normal. In this case, my area is 20%. My mean is 591. And my standard deviation, which I now know, is 5.19. In this case, we're looking at the left area because we're looking at anything less than 20% or the 20th percentile. And I'm going to paste that in and I get 586.63, which would be 587 mil rounded to the nearest whole number. So that would be my smallest 20%, 20th percentile, which would be rejected. All right, question 17. We're still on probability. So we've got here 326 lecturers, and of those, 303 said that they've had a mobile phone ring in a lecture they were giving. We're wanting to determine the sample size required for a follow-up survey that provides a 95% confidence that this estimate is correct to within 0.02 of our population proportion. So in this case, first thing I want to find is what is my sample proportion. So that's going to be 303 over 326, which is 0.9294. And I've also got down here as well more information that we're given in the question because we're looking at the 95% confidence interval, and that's my Z equals either plus or minus 1.96. Now what I'm going to do first up is I'm going to do this division, 303 divided by 326. So there's my population proportion. Now you can see I've got quite a lot more decimal places there than what I kind of wrote down initially. And I'm going to again store that. I'm going to store that under P for population proportion. And that then when I use my calculator later on, I should be able to get a slightly more accurate value than just the rounded one that I would have used initially. From here, we're wanting to determine sample size. So we know what our Z-score is, and we know we're doing a 95% confidence interval. So we can use our confidence interval formula, which is our population proportion, plus or minus 1.96, and then square root of that same proportion, 1 minus P over N. We want to solve for N. So again, I'm going to use that same numeric solver that I used before. And in here, I'm going to use, we don't have to have the plus or minus, the calculator won't like that anyway, so we can just pick either, and it's within 0.02% of the 0.02 of our population proportion. So that means either 0.02 below the mean or 0.02 above the mean. So I'm going to use 0.02 above the mean where my 1.96 is positive. Okay, so in my equation 1, I'm going to put in that upper limit using the positive 1.96. So I'm going to have 1.96 times by, now I'm looking at the square root of, now if you remember, I had stored that population proportion under P. So I'm going to have alpha P times by 1 minus P over X. And I'm solving for where that's equal to 0.02. So that's the within that value of our population proportion. So that's equal to 0.02. I'm going to go OK. Now what we should see is P comes up with that value there. So that says P equals 0.9294. We want to leave that. I'm going to highlight down to X. And if I go alpha solve, we can see we get 629.77, which we would round up to 630 people. Okay, this second last question in the exam, we're solving for our quadrilateral ABCD, and we want to find what is the perimeter of that quadrilateral. I did this question probably actually not in the most straightforward way. So, and the really nice thing about geometry questions is that there's so many different ways you can go about solving it. So I'm going to talk you through the way I did it, and then I'll show you probably the faster way if you wanted to do the most streamlined, efficient way of solving the question. But just remember, there's plenty of different ways you can do it. So just go with whatever feels right for you. So when I was solving this question, the first thing I want to definitely do is my calculator's on radian mode, and I want to change it to degrees because it's a trigonometry question where we've got angles in terms of degrees. From here, I'm going to use cosine rule to solve for the length of b to d. So if I imagine I cut that quadrilateral in half, turn it into two triangles, I'm going to solve for what that value is there. So I had 4.1 squared plus 7.6 squared, and then those same values substituted in for a and b and multiplied by cos c, which is 117, and I came out with 10.1. The next thing that I did after that, and this is probably where it's varies a little bit from maybe what some other people would do, is I then, if I know that length there is 10.1, I then used sine rule with that angle, which is 62. So I did my sine c over c and sine d over d to solve for the opposite angle to that 5.4, which gives us that BDC angle there. So I solved for that. That gave me 28. So I did sine 62, and I'll talk you through this one on the calculator quickly. So I did sine 62 over 10.1, and then I knew that to solve for sine d, I'd have to multiply by 5.4. So I just did that all in one step. 5.4, and that should give me 28 degrees, because I haven't done the most crucial step, which is taking the inverse sine of that answer to then give me my 28 degrees. Then I knew that if I had 68 plus that 28, and I can just copy down that answer by using the arrow togs there. So if I had 68 plus that answer, altogether that gives me 96. And if I minus that from 180, that gives me 80. Oh, sorry, I've used 68 there. I should have used 62. But instead of redoing all that calculation again, I'm going to copy that, bring it down, and I'm just going to scroll through and change that to a 2. So 62 plus 28, so that gives me 90. So I know that if those two angles there added up to 90, that means that my angle from DBC, that also has to be 90 degrees. So that angle at B is 90, and therefore I use Pythagoras to find that D to C is 11.45, and therefore my perimeter was 28.6. Now, the other thing that I could have done, if I wanted to do this in maybe a little bit more of a succinct way, is I probably could have used cosine rule again. And again, I probably could have used that same numeric solver that we've been using a lot, which really comes in handy in the methods course. So in this case, I'm not solving for my side C because I know what the side that's opposite that angle 62 degrees is. In this case, I'd be solving for either A or B. So my C, that 10.1, I'm actually going to use that as equation 2. And for my first equation, I'm going to have 5.4 squared plus x squared. So that unknown I'm going to replace for B, minus 2 times by 5.4 times by x. Again, we've got another lot of x. And then times by cos C, which is 62 degrees. So from there, I'm going to take down, again, my C is the one that's opposite the angle. So in that case, I'm going to use 10.1 and square that and hit OK. Now I'm solving for x, and I can see there I get 11 point. This one's going to be slightly accurate because I have had slightly more accurate because I did have to round a little bit throughout the question. So in this case, I'm going to get 11 we'll say 0.44 rounded to 2 decimal places. In the question, you only have to round to 1, so it would still be 11.4 really for both. And the perimeter should be pretty much the same as well. So that's a slightly more streamlined way of doing it. But again, nice thing about geometry is you can really pick your own way of trying to accomplish the question. Second last question here, question 19. We're told we're driving along a road which is a vertical distance above sea level given in meters, and it's got this nice function 300 plus the natural log of x squared minus 3x plus e. X is our horizontal distance from our initial point of measurement, and if we're east of the initial point, our value of x is positive. If we're west, it's negative. We're starting from 10 to 10, so we're starting from 10 kilometers west, we're ending up 10 kilometers east, and the last little bit of information we're given is that we're driving downhill at an average speed of 40 kilometers an hour. So I would really like to get a nice visual of this to see when I'm actually driving downhill, and from there I can do a little bit more calculating. So I'm going to sketch the graph of this function, 300 plus the natural log of x squared minus 3x plus e. And we are given kind of set values of negative 10 and 10 from where we're going, but I want to get an idea of where I'm going to set the graph up with first. So I'm going to use that same zoom fit as well. So if I go up to 0, that gives me a zoom fit. Now this isn't going to give us a particularly nice graph because where zoom fit doesn't always give you the region of the graph that you're interested in. It just gives you kind of the best, what they consider to be the best bit of the graph. Now I'm going to adjust this in my window, and I'm going to set this up from negative 10 to 10. But I'm going to keep that y min and the y max there, so I don't have to go around kind of searching for it later on. I might need to adjust it again, but I'm for the moment kind of not too unhappy with that. And there we can see the graph really nicely. I do actually just want to take that y min down a little bit just so I can see the bottom of that graph a bit more nicely. So I'm going to change that to 295. And there we can see the graph really well. So I can see that I'm driving downhill all the way up until we reach this minimum point here. Now, again, a couple of different ways that we can find that minimum point. The first one is just using the calc menu on the graph. So we go second, calc, and we're looking at the minimum, where you can select number 3. And all we have to do is press enter once left of the minimum, once right of the minimum, and then around about the middle. Again, it doesn't need to be perfect, and we can see we get to that minimum at x equals 1.5. The other way that we could do that is we know the minimum occurs where we've got a derivative of 0. So again, in that numeric solver, I can put in a derivative into that expression 1. So if I go alpha f2, scroll down to number 3, which is the derivative, I'm deriving the equation that I put in y1 to begin with. So if I go alpha f4, I can select that y1. I don't even have to retype it. And I'm deriving with x with respect to x, but I'm solving for where that's equal to 0. I'm going to select OK again, and I can see that my x value equals 1.5. Now that x already came up as 1.5 because we'd already solved for x as 1.5 back when I found the minimum just from doing it graphically. So that's why that already appeared, but that won't always be the case. Make sure you always press alpha and solve or enter to find that variable. Okay, so that means that at x equals 1.5 or 1.5 kilometers east of the origin is where we change from going downhill to going uphill. From here, we're wanting to find the total distance that we spent going downhill. So we've been given the formula to find the length of a curve back up in the top of the question. And I'm going to integrate from my lowest value, which was 10 kilometers west or negative 10, up to 1.5, positive 1.5. So I'm going to go alpha F2, select my integral. Now I've got 10 at the top as my, 1.5 as my upper bound, negative 10 as my lower bound, and my formula is for 1 plus the derivative, I should put in my square root, apologies, so second square root 1 plus. Now I want the derivative of that y1 that I used before. So again, I can use alpha F2. I can insert my derivative in here too, again, of that y1, deriving with respect to x. And I'm going to take the square of that. So I do need to square this as well. I'm going to go back. If I press second insert, I'm just going to put some brackets around that just to make sure that I'm only squaring that and nothing else. And again, integrating with respect to x. Again, this will take a little while because the calculator does do a derivative and then integration. So if it does kind of have that little turning symbol at the top, don't stress too much about it. It'll happen eventually, and we end up with 13.25 kilometers being the total distance that we've traveled downhill from. Now we haven't quite answered the question because we want to spend the time we're driving downhill if we're driving at an average speed of 40 kilometers per hour. So my formula for speed is distance over time. My total distance, my speed is equal to my distance over time. So that's 40 over my distance is 13.25 over time. So therefore I know I can rearrange that equation. So if I copy that down, divide that by 40, I can see that my total time I'm going downhill is 0.33 hours. And if I wanted to, I could times that by 60 and convert that into minutes. So 19.88 or approximately 20 minutes is the amount of time I spend driving downhill. Okay, the very last question on the paper looks at the difference of two sample proportions. So we're trying to decide whether town A or town B, whether if where you live determines whether you like tea or coffee, or whether you drink tea or coffee more. So we're given some amount of people who drink tea, amount of people who drink coffee, and a total number of people for both towns. What I have here is down the bottom is I've just worked out those sample proportions as fractions, but I'm going to put them into decimals on my calculator. And again, I'm going to, same as before, store them under certain variables. So in this one, I'm going to store this one under A for town A. So that was the number of people, the proportion of people who like tea. So 111 out of 216. Again, I'm going to store that as A. For town B, I'm going to look at T again as well. So I've got 150 out of 257. And this one I'm going to store under my B variable there. So this is I've got a proportion of people who like tea in town A is 0.5139. And my proportion of people who like tea in town B being 0.5837. Okay, rounded to 4 decimal places. Now we want to use our 99% confidence interval for the difference of two proportions to determine if there's evidence to conclude that drink preference is associated with with the town the person lives in. So the next thing I'd need to do in this question as well, after finding the sample proportions, is I want to know what is the z-score for the 99% confidence interval. So if I didn't know that off the top of my head, I would go second distribution down to inverse normal. My area is 0.99. That's my confidence interval. We're looking at z-score, so mean is 0. Standard deviation is 1. And I'm looking at the center area in this case. We're looking at everything except the 0.005 area on either side of the normal distribution. So if I paste that in, I can see I get negative 2.5758, which I have there. So from here, I know what P1 is, I know what P2 is, and I know what Z is. So now I can just substitute these into the equation that I'm given at the start of the question. So again, like I said, I stored P1 under A and P2 under B. So when I do this, I'm going to have A minus B, just going through using that same formula that we're given there, minus the Z score, which is 2.5758, times by the square root of, now I'm going to put in a fraction here, alpha x, nice quick way of getting the fraction, P1 times by 1 minus P1, so that's A times by 1 minus A, over N1. Now that's the number of people who live in town A, so 216. Then I'm going to have plus, again, put in a fraction, P2, which was B, 1 minus B, over the number of people that live in town B, which is 257. Okay, so this is going to give me my, my lower limit of my 99% confidence interval for the difference of those two proportions. So I press enter and I end up with negative 0.187. Now to find the upper limit of that, I'm just going to copy that equation down. So again, if you press up, then hit enter, I'm going to copy that down. Now the only difference between the lower and the upper one is that that negative in front of the Z score is changed to a positive. So I'm going to go through, I'm going to change this to being plus 2.5758. And then I'm going to hit enter, and this gives me 0.0483. So that would be my upper limit of my confidence interval. Now looking at those there, I would say that we're also told back in the question, where is it? If our approximate confidence interval for the difference of the two proportions does not contain 0, this provides evidence that the two proportions are not equal. So as this confidence interval does contain 0, I would say that there is not enough evidence. But I might want to recheck that looking at my proportion for coffee instead of tea. Now, if I did want to do that, I could take 105 over 216, so this is my proportion for coffee instead of tea in town A. I'm going to store that again as A, and I'm going to do the same thing for B. So I'm going to take 107 out of 257, and I'm going to store that one there as B. Now I've changed what the variables represent, but I haven't actually changed the equation that I was looking at before. So now if I go all the way up to where I had that first 99% confidence interval equation there, I'm going to copy that down, and that's just going to recalculate that using my new values of A and B. So if I hit enter, now I get negative 0.0483 for my lower limit. And I'm going to copy the positive version down as well, and I get 0.1879 there for my my upper limit as well. So again, contains 0, so not enough evidence for that question there. And there we go. I believe that is the final question on the exam, and hopefully that shows you a little bit how you can use your technology to answer those questions. Thanks very much.